Have you ever wondered what causes the thunderous boom when a jet flies overhead at supersonic speed, or the mysterious cone that forms around the aircraft? Welcome to the enigma of sonic booms and vapor cones, an intriguing intersection of physics and aviation. These phenomena are no magic trick or alien technology, but rather, they're tied to the speed of sound, and that's just the tip of the iceberg. In this journey, we'll unpack the science behind these occurrences, from the formation of vapor cones, which are often mistaken for the sonic boom, to the actual effects of the sonic boom itself. We'll explore how these supersonic jets manage to break the sound barrier and what happens when they do. We'll also delve into the role of atmospheric conditions in these phenomena, and how changes in air pressure and temperature can dramatically influence the visibility of vapor cones. So buckle up and prepare for an exciting ride into the world of speed and sound. Stay tuned as we delve into the science behind these fascinating occurrences. Ever noticed a cone-shaped cloud forming around a high-speed jet? That's a vapor cone. Vapor cones, also known as shock collars or sonic booms, are fascinating phenomena that occur when an aircraft is zipping through the sky at transonic speeds. But what exactly are transonic speeds, you ask? Well, these are speeds that are near or slightly below the speed of sound, which is roughly 768 miles per hour. Now, as the aircraft surges forward at these blistering speeds, it compresses the air in front of it. This compression leads to a sudden drop in air pressure and temperature around the aircraft. And here's where it gets interesting. The drop in pressure and temperature is so severe that it causes the water vapor present in the air to condense. This condensation forms a cloud which is visible to us as a cone-shaped formation enveloping the aircraft. It's like the aircraft is wearing its very own cloud cloak. What's even more intriguing is that this cone-shaped cloud isn't stationary. Instead, it moves along with the aircraft, maintaining its shape and size relative to the aircraft's speed. The faster the aircraft, the tighter and more defined the cone. So the next time you see a cone-shaped cloud enveloping a jet, you'll know it's the result of the aircraft pushing the boundaries of speed. Now let's tackle the loud boom you hear when a jet zooms past. That's a sonic boom. Imagine this, a jet is cruising along at a speed just shy of the sound barrier. Suddenly it accelerates, crossing that magical threshold known as the speed of sound. What's happening here? Well, as the aircraft breaks the sound barrier, it's essentially outrunning its own sound waves. This leads to the formation of pressure waves. These pressure waves are initially distinct entities, but as the aircraft maintains its supersonic speed, these waves start to merge, combining into a single powerful shockwave. This shockwave races through the air at the speed of sound, trailing behind the aircraft. And that sudden thunderous boom you hear? That's this shockwave reaching your ears. But sonic booms do more than just create noise. They're powerful enough to cause noticeable vibrations on the ground. If you've ever felt your house shake as a jet flies overhead, that's the sonic boom at work. In extreme cases, these booms can even cause damage, shattering windows and even cracking plaster. However, it's important to note that such damage is rare. Modern supersonic aircraft are designed to minimize the impact of sonic booms, and flight paths are often carefully chosen to avoid populated areas. Interesting, isn't it? The powerful sound you hear is nothing more than the result of pressure waves from a fast-moving jet. We've taken quite a journey exploring the science behind sonic booms and vapor cones. We've learned that sonic booms are the thunderous sounds we hear when an aircraft surpasses the speed of sound, while vapor cones are the visible shock waves formed under similar conditions. They're not just spectacular to witness, but a testament to the fascinating interplay between physics and aviation. So the next time you witness these phenomena, you'll know exactly what's happening in the skies above.